Okay, the first law of thermodynamics is basically conservation of energy. So really, the first law of thermodynamics is energy may neither be created nor destroyed. But when we actually start talking about it in physics, we use it in other terms because we're talking about thermodynamics. So we're talking about how it relates to heat. And remember that when we did some of our activities, we lost energy due to heat. Well, the first law of thermodynamics actually allows us to quantitatively figure out how much heat that is. So, basically, this is the equation that we're going to use for the first law of thermodynamics. We're going to have the change in internal energy. That's what U is. Change in internal energy of a system. And that's the internal energy is why things get hot. Remember, when you rub your hands together, you have friction going on there, and that makes your hands warm. That's the internal energy. You did work on your hands, which changed their internal energy. So you didn't add any heat. You didn't make your hands warmer by adding any heat, which is what Q is. You made your hands warmer by doing work on them. So they got warmer, is basically what it's saying. So delta U is our change in internal energy. It's related to the temperature. Okay? So when our particles are moving faster, that's because they are hotter. And that's how we sense an increase in internal energy. Q is heat, just like when we're doing Q equals MC delta T, when we're doing Q equals ML, it's still heat, and it's heat added to the system. And then the work, now this is a little tricky because sometimes you will see Q minus W, sometimes you'll see Q plus W. And the reason you'll see Q plus W is because they're defining the work done differently. The way that we're going to use it is the work is done by the system. So the system itself is doing work. So when it's doing the work, then it's going to be a positive W. If work is being done on it, because that's how you get Q plus W, if work's done on it, then you have a negative W and you have a negative negative, so it makes it positive. The AP books do Q plus W. Your whole textbook does Q minus W. And so that's why we have the two different forms. We're going to use the Q minus W. And if you ever have trouble remembering which order they're in, alphabetical. If you put them in ABC order, it's Q minus W. I always got that confused. Okay, so each term has its own kind of meaning of its sign. So delta U is our internal energy. And so if it's positive, that means you have an increase in your internal energy and it's going to get hotter. If you have a negative delta U, that means that you have a decrease in internal energy and it gets, it's going to get cooler. Okay, so positive delta U, hotter, negative delta U, cooler. So when you're reading the wording of the problem, think of this. Q, all right, if it's positive, that means the heat went into the system, so it was endothermic. If it's negative, that means the heat is removed from the system or it flowed out of the system, and it would be exothermic. And then work, because this is the tricky one. The work is the tricky thing. It's the work done by the system. So if we're talking about a gas, that means the gas expands. It gets bigger. Your volume increases. So use this, what happens to the gas, to see is the system doing work or is it being done on it. A negative means the work is being done on the system. It's contracting or it's compressed, and your volume gets smaller. So This might be a handy little chart to put on your handy dandy equation sheet just because it makes things a little bit easier. So let's look at how we would. All right, so let's look at number 5 here. Okay, as a hot air balloon cools down, that's a change in temperature. So it got cooler, and temperature is related to which one? Yeah, temperature was related to delta U. And if it gets colder, then it's a negative delta U because it got colder. Okay? And then it is compressed by the air around it. So the air around it is the system, and it got compressed. So that means the work is done on it. So we actually have negative work. It got compressed. So the work is done on the system. See how we're using the wording to figure it out? Okay. So identify the sign of the heat, the change in energy, and the work. So nobody said anything about it gaining heat or losing heat. So let's think about this. We have it. Here's our equation. Delta U equals Q minus W. All right. So if delta U is going to be negative, and W is going to be negative, so this is a negative negative. You see that? That's a negative negative. So that's going to make this whole term here. This whole term here is going to be positive. So the only way that this can happen is if Q is negative, because this answer needs to be negative, and then we have a number with a positive number behind it. So the only way that delta U can be negative is if Q is negative. And so we basically solved delta U equals Q plus W to get that. Okay, we really have nothing in the problem itself. Hot air balloon cools down, so that's its change in temperature. It's compressed, but nobody said anything about heat. So we had to get that by doing some other things. Okay? Good to go on that one? All right, so why don't you pause this right now, look at number 6, and check your answers. I hope you paused it before you checked your answers. But our delta U is going to be positive because we raise our temperature. Our Q is going to be negative because the walls got warmer. The walls are part of the surroundings, so the heat flowed out and made the walls warmer. So Q, remember, is heat. And then it got compressed, so our work is also negative. All right, let's do this with some numbers now. Okay, so let's look at 8 here. We have a platter of birdseed mounted on top of a gas-filled piston. As the birdseed on top of the platter is eaten, the gas expands. What's that mean? That means our work is positive. Good. It expands isothermally. Ooh, there's a big word. Isothermally. What does that mean? Remember that from your definitions. Isothermally means iso, same, thermal, temperature, same temperature. So that means that our delta U is 0. And so we have this much work. So our delta U is 0. So if we're going to use delta U equals Q minus W, 0 is equal to Q minus 4.17 joules. And so that would make our Q a positive 4.17 joules. What does that mean? That means the heat went into the system. That means it had to take heat from the surroundings to make that happen. Okay? So heat, temperature, not the same thing. Heat, temperature, not the same thing. All right, one more. We'll do 10. Okay, a system releases 125 joules of heat, so it releases it. So that means our Q negative. So if the work is done on the system, that means that it's negative work. Because remember, a positive work is done by the system. So we have the work is negative 104 joules. Calculate the change in internal energy. So our delta U is equal to our Q, negative 125, minus a negative 104. See how that works out? And so you have this minus a negative. That means you're adding, right? Subtracting a negative, you're adding. So negative 124 plus 104, that comes out to a negative 21 joules. That would be our delta U. So what happened to our system if it has a negative delta U? Yup, it got cooler. Okay? It doesn't always get cooler when it loses heat, but a lot of times it does. And so that should get you a pretty good start on your practice problems. Thank you very much. Good luck. Bye-bye.